Okay, and we're live. So, really, for those of you who don't know, I record my lectures and I post them on YouTube so you can have a record of all the classes. Don't think you can just not show up to class and watch the videos, because I do take attendance and I do actually grade you for attendance, so there is a lot of use to actually showing up. And there's no eraser here.
Still one.
I have a little bag of treats today. This is actually my 5th class today, so if I seem a little bit disorganized, I don't know what I'm carrying from one class to the other anymore. I'm surprised I was able to get the right syllabus, but yeah, I'm gonna steal an eraser and be right back.
Told you.
In the meantime, read the syllabus.
What's the ratio?
Yeah, exactly. I don't think it's something like right. Oh, let's assume it's on Thursday. 60%.
Isn't that fucking bullshit? That's like you can't get anything right.
I thought that was oh wait, because I feel like what was it? Okay, that was work at least. I think we have already sure. Oh yeah. Because you typed in something wrong, like you forgot to make the pronunciation. So it's too cool. I'm glad that we actually enforce this homework though. We actually have to practice. The last class.
That's the reality in these city college streets. Teachers have to be stealing erasers from each other. It's real. And markers too. My next class has a whiteboard, so I decided to just preemptively steal something. I don't even know if I'll need it or not. But hey.
Professor, this is a lot of quizzes and tests, you know. I looked at the syllabus.
We'll have a quiz every week.
That's excessive.
Not excessive. Especially given the fact that for this class, well, let's start over. We'll like edit that out or something. Welcome to Math 392. So for this class, one thing I will say is that your Calculus 3 is very, 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 very important. And so I would have to kind of give you a lot of work to kind of get used to that. Because if you look at something like Calculus 1, well, what are the things you need to be good at Calculus 1? You have pre-calc to fall back on. You have algebra to fall back on. You have all of high school to fall back on, right? Like if you paid attention way back in high school, calculus is not a big deal. Same for Calc 2, you have so much to fall back on. Calc 3 is kind of new. It's like you have to be thinking in a way you never thought of before. And so it's hard for your mind to actually grasp the new concepts. So because it's something you're not used to, it's something that I'm constantly going to be trying to drill into you. But it's going to be very important. So again, this is Math 392. Make sure you're in the right class. Usually the people who take this class are engineering majors, sometimes physics majors might take it. If you're a math major, this is not the class you should be in. But yeah, so just make sure you're in the right class. So it's Math 392. This is section S, I believe. Okay, my name is Jhevon, as you can see here on the syllabus. This is my contact email, so in case you need to email me, that's the email I'd like you to email me at. My website is also listed there. You will find information for the class at that website. So if you go to that link, you will see a list of all my classes. So you go under Spring 2018 classes. So go to website. Then go to Spring 2018 classes. Select this class. I'm teaching 2 classes at City College this semester, so I'm teaching a 346 and a 392. So you go there, you select this class, and you'll find a lot of materials there. So one, the syllabus will be there, so I put a PDF of the syllabus there in case you lose the physical copy. As well as I'll be posting reviews there, I'll be posting answers to quizzes there, I'll be posting solutions to tests there, I'll be posting announcements there. I'll post a lot of stuff there. Any handouts that I think you need to have, I'll post it on that website. So it's important that you have that website. We're going to be using 2 textbooks for this class. So there's Stewart's Essential Calculus, 2nd edition. It's been around a while, a lot of you should already have it. And there is Linear Algebra for Calculus. It's a small brown book, which we'll use towards the end of the semester. You'll notice, for example, this is kind of skipping ahead, but if you skip to the second to last page, there's a list of topics here that we'll be doing and suggested problems from the textbook that you'll do them. Part 2 happens right here. That's when we switch textbooks. So we will doing this section of the class from the Stewart Calculus textbook, and we'll doing this section of the class from the 2nd textbook. Calculators aren't allowed in class. You might have to use it on homework, which we'll get to, but not in class. Grades, the usual grading chart. Here's the grade breakdown for the class. So the final exam is 40%. I have no control over that. That's departmental policy. The other 60%, this is how it's going to break down. You get 15% for quizzes, and again, expect 1 quiz every week. Homework will be 10% of your grade. That's going to be assigned online because I'm not going to be grading all your homework. So forget that. My other class is just as big. There's no I'm going to be grading all these. Okay. In-class tests, that's worth 30% of your grade. I'm going to give 4 exams and I'll count the best 3, so you can think of 1 exam as counting as 10% of your grade. Participation, which is mostly attendance, is going to be 5%. But I'll notice other participation. I like when the students talk back to me and I can kind of see what you guys are understanding from what you're not understanding. So yeah, the attendance, show up, the usual policy. If you have more than 5 unexcused absences, you can fail the class with a WU. Moving on to the next section, next page. My expectations from the class. So I want you to know what I expect of you. For one, no slacking off. You need to work hard. If you know in your heart of hearts that you are you're not strong on your prerequisites, if you're sitting there and you know deep within yourself, you know what, I'm probably not that good at Calculus 3, right? You need to be honest with yourself, and you need to make sure you get good at Calculus 3 in like a week, okay? Because it's going to be very important. You're going to realize. This course I will go as far as to say, if you're a very strong Calculus 3 student, this course will be very easy for you. In fact, I personally never took this course. Because I was a math major, I didn't have to take it. But I worked in the tutoring center for a while, and I know students will come in for this course all the time, so I figured, you know what, let me teach myself this course. I'm usually not so diligent, but there was one time when I was on vacation, and I was staying with my grandparents. They had no internet. There was no entertainment. I didn't have a car, and this was in Florida, so you can't get anywhere without a car, really. The only resource there was a library, and the internet sucked, so I actually found the textbook and decided I was just bored out of my mind. You know what, I'm just going to actually study 392 on my own. That might, it'll take me my entire summer vacation, blah, 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 blah. Problem with that was, I was very good at Calculus 3 at the time. I finished the entire course in like a week. because it was like, this is just like Calc 3. Oh, this is just like Calc 3. This is just like Calc 3. Like, did all the problems in the book, and it was like, well, that was just like Calc 3. Like, I didn't feel like I actually learned anything. I just learned a bunch of new formulas where I'm applying Calc 3. The linear algebra part of the class is also not going to be bad, but overall, the meat of this class is you're going to need a lot of Calc 3 to actually fully understand it and, you know, not rip your hair out. So if you're not good at Calculus 3, you need to be good at Calculus 3, and I expect you to work hard to make that true. Yeah, so prerequisites, I expect you to remember every math you've ever done in your entire life for this course, and Calculus 3, I rely on that heavily. This course just does that. Of course, I expect you to be responsible. No begging for grades at the end of class. Professor, you know, I need to keep my scholarship. It might sound mean, but it's not my responsibility to keep your scholarship. It's your responsibility. Don't wait until the last day to come and complain to me about your grade. You need to always be on top of it. It's your responsibility to maintain whatever requirements you have to maintain, right? So as long as you come to me early during the semester, I will help you, and we will go on, and you can always talk to me. But don't expect to, like, me not see you and just come to the end of at the end of the class and try to get away with it. It's not going to work. Homework is the next section. We will have online homework, okay? You can access the online homework with the instructions on the next page. Okay? So that's the link you're going to go to. You're going to click on the class that says this one, 18 SP 392S. That's the 2018 Spring 392 class. Your login is your username of your email. I believe it was all uppercase, but it might be all lowercase right now. I think they probably fixed that. But at the time when I wrote this, for some reason it only accepted all uppercase. You can try it. If you have a problem, you can let me know. Password is same as your email password, and they're linked. So if you change your email password, your login for this will also change. They're always going to be the same. Okay, the next section, blasphemies. So because you're all very experienced math students, there are certain mistakes that I have a zero tolerance for. Literally a zero tolerance for, because I will literally give you a 0 if you make any of these mistakes. So because that's harsh, I kind of want to actually go through some of these mistakes with you. Some things that I expect you not to make, they cause a lot of trouble. So, about the blasphemies, for example. First one is canceling across sums. At this point, you should know that you should not cancel across sums. What do I mean by cancel across sums? For example, let's say you have something like, okay, 2x plus 1 all over 2. Where you go, cancel the 2's. No, you cannot cancel the 2's. If you decide to cancel a 2 and you write x plus 1, I give you 0 for that problem and I move on with my life and I don't read anything else you write because I'm like, this person doesn't know what the hell they're talking about. Okay? Do not cancel across sums. If there's a plus or a minus sign separating terms, you cannot cancel. Okay? You can only cancel across multiplication. So if you have a 2 times an x plus 1 over 2, here you can cancel because there's a multiplication. Do not think you can cancel something when there are pluses and minuses separating them. And you can cancel one part and leave the other part with nothing happening. Math doesn't work that way. Okay?
Would you have allowed an x plus half though?
Huh?
Would you have given us?
Well, that is the same thing.
So would you have allowed that? Yeah, the right.
Yeah, sure. Because that would be correct. Yes. This is actually incorrect. Demonstrably so. Okay. 2. The second thing I do not expect anyone to do. Well, there are quite a few here. Kind of added to the list of it. Distribute powers across sums. I should probably be writing here, don't. So no one can say, you told me to cancel across sums. No, I said don't do it. Okay. What do I mean? For example, let's say you see something like x plus 2 all squared, and you're like, that's just x squared plus 4. No, that is not x squared plus 4. Right? one common mistake that I see is students often forget that radicals are power. So a lot of times students will come up to something like, oh, x squared plus 4 under a radical, and they're like, oh, that's x plus 2. It is not x plus 2. Okay? What you are actually doing here is the radical you have to remember is a power. It's actually the half power. So what you actually said was, this half comes here, makes that an x, and then it comes here, makes that a 4. That's not how powers work. You don't distribute powers across sums. Right? If you want something like x plus 2 all squared, there's a whole rule to go through with that. You can remember that that's what it means, and so you FOIL it out. Or you can just remember the fact that a plus b all squared, which at this point I expect you to remember that. What's the formula for this? Right, so this guy would actually expand to x squared plus 4x plus 4, right? So when you say this, you're literally missing an entire term, okay? And it's not the kind of mistake I expect you to be making at this level. Here's another thing that, I don't know why this is still a thing in 2018, but don't divide by 0. If you end up with something like 1 over 0 and you tell me, oh, that's 0, or that's infinity, you don't know what you're talking about. You cannot divide by 0. Okay? It's a completely different thing to say something like the limit as x approaches 0 of 1 over x squared is infinity. That is a factual statement, but your x never actually equals 0. You have to be aware of that. You cannot divide by 0. It doesn't make any mathematical sense. It's easy to prove that if you can do that, you will literally destroy the number system. Math ceases to be a thing if you allow this rule to work. Another thing. What's the integral of 1 over x?
ln x plus c.
No.
I know, absolutely.
ln of absolute value of x plus c.
That's what I meant.
Okay. That's not going to work. It's not what I meant. Okay, you have to actually write down what you mean. Okay. One mistake that I sometimes see students make is they'll sometimes see something like 1 over x squared. And then they'll be like, oh, that's ln of x squared plus c. No, that's not ln of x squared plus c. What is that? How would you integrate 1 over x squared?
1/2 ln.
Huh?
1/2
Put the
Negative.
1
No.
It's x to negative.
You rewrite it as x to the minus 2.
So, and then x to the minus 1.
Then it becomes
X to the minus 1.
over minus 1, right? It's the power rule, x to the n over n. X to the n plus 1 over n plus 1. So that's how you do it. Has nothing to do with an ln. As you guys clearly see, a lot of people just believe once you have 1 over something, there's an ln somewhere. That is not true. Okay? You only can get an ln if you have 1 over a linear function. Okay? So if you have 1 over ax plus b, or mx plus b, that gives you an ln. That's the general kind of function that gives you an ln. Right? So that would give you 1 over a ln of ax plus b. Right? So that's a general formula you can know. So either your integral has to be this, or after a substitution, it has to look like this. But you will never have any other thing giving you an ln from an integral if it's not a linear function underneath. Right? If it's a quadratic, it's not an ln. You have to rewrite it. Okay. Another thing, don't distribute derivatives or integrals over products. Okay. At this point, I would expect that you know things like the product rule or integration by parts. or anything similar to that. Anything that you would have learned in Calculus 2, I will hold you accountable for it. Okay? So if you see something like, oh, integral of x e to the x, and you're like, oh, just integrate this one, x squared over 2, and then integrate that one, you get e to the x, and that's the answer. That is not the answer. That is not how you do such an integral. Okay? You guys laugh. I see these things all the time. You have no idea.
Let us use the tabular method then?
Yeah, right.
Okay.
You can use the tabular method, but integration by parts, if it's one step, I would probably use integration by parts, but the tabular method can work. Right? The tabular method, you more use the integration by parts, you have to do it over and over, like something like that. Then yes, definitely I'd do the tabular method. But don't think you can just integrate this part and integrate that part and it works. Similarly with derivatives, I ask you to differentiate x to the fifth e to the x. You should know that there's a whole product rule. You don't just differentiate that and stick them together. That's not how derivatives work. Okay? So the product rule, the power rule, the quotient rule, the chain rule, implicit differentiation, various integration techniques, integration from the basic formulas, integration by parts, integration by partial fractions, integration by trig substitution, integration by all that stuff I expect you to know. Okay? And I don't expect you to be making these mistakes. Other common mistakes. Well, this is 6 star, because technically it's not something that you shouldn't do, something that you should do. Do use your parentheses. Okay. So let's say, a stupid example. Let's say f of x equals, yes, I know we're all beyond this, but just bear with me. And you want to compute f of x plus h minus f of x over h. What would that look like, by the way?
2 times x plus h. Put the square on top, and then plus 1, and then minus, put a parenthesis, 2x squared plus 1 divided by h.
Okay, I never mentioned this, but a lot of people just recopy this and put a plus h at the end for this. Like, that's also something. I probably should add that to this. Because, yeah, if you do that at this point, like, okay, it's too much. But one thing that students of all levels will do, they forget to use the parentheses here. Right? If you're subtracting something, put it in parentheses. If you're multiplying two functions, put both of them in parentheses. Because a lot of them have the philosophy that, I don't know who said it, is that, oh, that's what I meant. You know, some people would like not write that. Like, you know what I mean, right? So the problem with that is sometimes you forget what you mean. Sometimes you're in a test and the problem is so long, you have like 10 steps. You didn't write the parentheses up here, but you know what you meant. But by the time you get down to step 9, you forget the fact that you knew that there was some invisible parentheses there that you had to remember, and Jhevon's like, 5 minutes left, and you start freaking out. You're not going to remember that you know what you meant, okay?
So
I
you give
see
a
it all the
partial
time.
credit? You give a partial credit?
Well, I mean, the answer is going to be very different if you leave this off as opposed to not leaving it off. It would depend on the problem. Sometimes there is a case where the answer should be obvious. Like, if we continue this example, for example, okay? What would have happened here? Let's continue with this. I know it's Calc 1, it's beneath you guys, but let's continue. What would have happened here without the parentheses? Let's say this person forgot to use the parentheses. What would it look like?
4x squared
Plus
plus
4x8
4x plus 2h squared, and then plus 1 minus 2x squared plus 1. And then divided by h.
Okay, what would have happened here? This would have canceled, right? The ones should kill each other, but because we forgot our parentheses, they don't. So what would have happened? You would have gotten 4x 2h squared plus 2 over h. Okay.
You cannot do anything.
So now in this particular instance, it's hard to answer your question completely because it really would depend on experience. If I'm asking someone to do this, normally it would be in the context of a derivative. And I would expect the student to know that at some point you need to plug in h equals 0. I would also expect the student to know that I can't plug in 0 in the denominator because blasphemy. So the fact that a student would come here and say, that's an answer, it means more to me that they didn't do it correctly. It means more to me that you didn't even get the concept of what your answer should have looked like. It means you're forgetting another basic fundamental fact other than the actual algebra that's there. Right? So there are contexts in which the algebra itself is not the point, but there's a higher meaning to what you're doing. And sometimes you would expect it to know better. So I would punish someone heavier for doing something like in this context than normally speaking. So if there was something where it's just algebra and it's not really consequential to the concept and you kind of make an algebra mistake, I'd punish you less severely than if your algebra mistake happens in the context of a larger formula that comes with it another concept that you should know that your answer should have a certain kind of form. Right? You should know that if you're doing something like this, the h needs to be cancelled. And the fact that you would tell me, here's the answer, and the h is not cancelled, that tells me that there's more that you don't understand than just algebra. Okay? So that kind of depends on that one. So for this particular mistake, I punish it very heavily, but it's hard to say. As well as a lot of the time, the computations is actually kind of less important. Let's say I'm giving you 10 points to do a certain problem. Sometimes just for the setup, that first line, or the first 1 or 2 lines, I'll give you like 4 or 5 of the points off the bat. And then I'd give you the other 5 based on the rest of your calculations, right? So if you set it up initially, and you set it up wrong because you forgot parentheses and all that, you're automatically kind of going to lose a lot of the points just automatically, right? Because sometimes I understand that, you know, when you're under pressure, you can make mistakes like that, but a lot of times the setup is going to be important. And I'll actually treat that a lot more important than normal. And in any given problem, especially if the work is very long, the actual answer, I'd probably give you like 1 point if you get the actual answer. It's much more important to me that you can set it up correctly and actually show some knowledge of mathematics in your working out. And if you make a mistake here, you get 9 out of 10 points. It's not a big deal. Okay? But you need to have a certain level of maturity, and I need to be able to see that, okay, here's someone, they're doing their due diligence. They didn't forget the parentheses. They understand the concept. They're plugging in things correctly. They didn't do a very stupid mistake like one of the 5 things that I mentioned earlier. Okay? So make sure you go over this list and you know that you will never make one of these mistakes, and go over it and make sure you understand fully. And if you don't understand fully and you come and talk to me, it's better that you talk to me now and I can show you even more examples, and so you don't have to make them, right? Because it's better that literally write anything else on your paper other than doing this mistake. If you get to this point and you're not sure if you can simplify and you think that you need to do something, write anything else, right? Jesus saves, anything. Just, it doesn't matter, right? As long as you don't do that, literally anything else you write is okay. I'd be like, okay, you know, all right. I'll give them some points. But when you do one of these mistakes, all bets are off. Like, you're dead to me. And I just like, I move on. Okay. Also, don't forget plus C when we're doing indefinite integrals. Those will be important. Contact. So I will also be emailing you guys. I keep track of your grades in an electronic grading system. It's not Blackboard, but your contact information that I loaded in that system comes from Blackboard. So if the email that you currently have in Blackboard is not the best way to contact you, you should contact me and let me know. Of course, you contact me at my email here. Okay, so I will be emailing you if there are any important announcements. I'll also email you a link to actually check your grades in real time. And so you can know what the record is I have for you. So that's actually very important. So make sure that you actually check whatever email you have in Blackboard regularly. Feedback, I encourage feedback. Even while I'm teaching, I expect you guys to be talking to me. I'm usually not going to be ranting at you all the time. I expect you guys, I'll ask questions, I expect you guys to answer, right? But even outside of class, you give me feedback if you think there's something more that I could do, or, because I'm not here just to write on a board. I want you guys to learn. I want to actually impart my knowledge, right? Just be constructive. So don't just be like, your teaching sucks. Say, your teaching sucks because, right? You don't do this, it's better if you, your handwriting, just be constructive, okay? In terms of help, lots of help, both on and off campus. So we have the Math Tutoring Center here in the Marshak building. That's the Ugly Science building. It moved recently, so it used to be in 418S, but it changed recently to 403. So those of you who have been to the Tutoring Center before notice that the location has changed. It starts on February 5th this semester, so I believe that's Monday. That's Monday, right? Okay, so as of February 5th at 12 p.m. Monday through Thursdays, Monday through Fridays, you will be able to go there and a tutor will be able to help you with this class. So if you ever need help. A lot of online resources as well. Most of you, I would assume, know about Wolfram Alpha. Okay, Symbol Lab. Okay, so there are things like that you can always use to check your answers. So if you're doing the online homework and you do my written homework, suggested problems, and you still feel kind of shaky, you want to practice more, maybe practice some even problems and you don't have the answers, you can use sources like that to actually check your work. You can, again, I listed some things, YouTube, Khan Academy, there are tons of things online. Just Google a random question that you might come across and you'll find some things. Your classmates are also another resource. I would recommend that you get the contact information of at least one other person you can study with. If you're missing, they can give you some heads up. Usual class rules: don't use cell phones. No eating. If you need to be drinking coffee or something, drinking is okay, but nothing that will have a stench. And remove your garbage. Don't cheat. The academic integrity policy, read it there. Okay, some important dates from the calendar. These are just selected dates. It's not the entire calendar. You should familiarize yourself with the entire calendar, but these are just some dates that I think would be important to pretty much everyone. So it tells you when late fees will apply if you want to change your course. It tells you when the college is closed, like for example, February 12th, college is closed. Tell you about the last day to drop before getting a W, things like that. It tells you when spring recess is. That's very important. It also tells you the final exam week. So that's, in this semester, it's May 18th to 24th. So you probably shouldn't plan to travel during that period. Also, May 30th is the last day to submit grades. So you should expect a grade for this class by that date, the latest. But I'll update you more on that as time goes on. Our final exam, though, we actually do know at this point when that is. Right, so you guys will be taking a group final because our class starts before 6 p.m. So I'm not writing your final, the math department will write your final and you'll take a general final with all the other 3-day sections of 392. And we actually know when that is. So that's actually Thursday, May 24th at 3:30 is your final. So don't go anywhere during that date. Again, these are suggested problems from the textbook. I will not be actually collecting them, but I think it will be very beneficial for you to practice them. And so between this and your online homework, which you will submit to me, you should be in good shape if you practice all these problems, as well as the reviews that I might give online. Okay. And on the last page, we have a questionnaire. I'd like you to fill it out and then just detach it. And then you can hand that in to me today. think it's 650.
Excuse me, Professor.
Huh?
Professor, don't you need to put your name?
No name.
No
It's
name?
anonymous.
Okay.
I just want to kind of get a demographics of the demographics of the class. And so be sure to hand those to me before you leave. Since I'm both standing here, maybe we can do something. Can you do that?
I have a question.
Yes.
For Calc 3, is it going to be about everything in Calc 3, or are there specific sections we should follow?
In terms of Calc 3, mostly the mechanics, like the computational parts. So you need to know how to compute an iterated integral. You need to know how to set up a triple integral, set up a double integral. Know about polar coordinates, know about cylindrical coordinates and spherical coordinates. Know how to graph a three-dimensional figure. And if I describe a part of a three-dimensional figure, you should be able to visualize it and make manipulations and find its volume and things like that. If I give you two three-dimensional surfaces and I can ask you for the intersection curve, you should be able to find the intersection curve. You should know about vector curves, how to differentiate them. You need to know how to take a cross product, how to take a dot product, what it means when you take a cross product, what it means when you take a dot product. What's the dot product? What's the result of a dot product? What kind of quantity?
A number.
It's a scalar, it's a number. Any particular number that's important when you're doing a dot product? 0. What does it mean when you do a dot product and you get 0?
They're orthogonal.
The vectors are orthogonal. What does orthogonal mean? Perpendicular means at 90 degrees. Okay, so something like that, for example, these are concepts that you need to know because orthogonal vectors are going to be important to us. A lot of forms that we have will be in terms of normal vectors. These are vectors that are orthogonal to a certain plane. So you need to be able to know when to find something that's orthogonal, for example.
You need the projections?
Huh?
The projections?
Projections, not really.
Taylor and Nicolette?
Series, not really, no. The series part, no. But series are important otherwise. So you probably should know about series, but we're not going to do much by way of series here. But just integration and differentiation, all their forms. The multivariable chain rule, just how to deal with vector functions, how to find the arc length of a curve, things of that sort. If I describe an object to you and I say find its volume, you need to know how to find the volume, how to do that by setting up a double integral or a triple integral. Yeah, how would you do this one? You guys have to just pass it to the person in front of you until it gets to the front row. You don't have to get out of your seat.
You integrate respect to y.
So what does this mean?
You integrate respect to y first.
In respect to y, how do you know? Well, these are in order of the integrals that they're being applied to, right? So you do the inside to the outside, okay? So if you were to do that, what would you get?
1/2 y squared.
Y dx.
What?
X plus y dx. The integral of x.
No, 1/2
X. X, y squared over 2 plus y 3 over 3.
Okay, thank you. Okay, and then you have dx.
And the x.
Then what?
So the x with the y to the 3 over 3.
Plus?
And then y cube plus 3.
Plus c.
Plus c. Okay, all right. Find volume bounded by z equals 4 and z equals x squared plus y squared. Include a sketch.
Equation of a circle. No, volume.
It looks like a cylinder. I think.
It's a parabola, and then it has the z equals 4 plane.
Paraboloid, right?
Yeah, so the
So-
z equals 4 plane
So how does it look?
with the parabola. Then I have the plane as z equals 4.
Right, so it's not a cylinder, it's a paraboloid. And then the top is cutting through 4, so that is the plane z equals 4. This is z equals x squared plus y squared.
And you're going from 0 to 4, and then integral.
Okay, what would this look? What would this be? What kind of object is that?
A circle.
A semi.
You made a circle.
It's a cone. Right, so if I give you that, you should know that that's this, right? It's a cone, right? It's only the top part. If I put the square here instead of a radical on that, you should also know that the bottom part of the cone now becomes applicable. Right? These are the kinds of things I expect you to know about. Anyway, let's continue with this one. Right, so yeah, I do expect you to be able to look at a formula and see a picture in your head and know the object. You should be able to recognize what's a paraboloid, what's a plane, what's a cone. What's a hyperboloid of one sheet? Okay, how do you continue? So that would be what the sketch kind of looks like. How do you continue? Sure, what integral? Give me 2 ways to find a volume. General formulas. When you say find volume, what are 2 things that you think about?
Area.
Integrate what?
The area? No, the surface area.
Give me like a formula. It doesn't have to be like super mathematical, but some description. Yeah.
So I was thinking like the cylinder from z equals 0 to z equals 4.
No, give me a general formula, a general idea.
Area times height.
Huh?
X times y times z.
No, not specifically with this. I want a general idea. Like if you had to find a formula for the volume, let's say in terms of a double integral, what would you think of integrating?
dA.
Sure, it's dA. What would you integrate?
I mean, the x plus y squared.
X squared plus y.
Again, don't look at this. We're going to apply it to this. I need a general formula, general description. How do you find a volume? Hmm?
Z.
Okay, what I'm looking for is top surface minus bottom surface, right? Whatever those surface happens to be here, right? So here, if you wanted to do a double integral to find the volume, the thing you're going to integrate is the surface on top, which in this case would be the double integral of the top surface is going to be a 4, minus the bottom surface would be this. Right, so when I say I want a general formula, a general idea of how to compute it. Okay. What if I had to compute a volume with a triple integral? What's the formula? 1. You always integrate the function 1, dv. Okay. Okay, so now that I helped you guys out with that, how would you complete this? How would you actually set this up?
Double integral.
Yeah, let's do the double integral now. So we know that that's the volume. How do you do it? How do you set up these limits?
The other one would be 0 to 4, and the other one would be from negative pi to pi.
0 to 4 and negative pi to pi.
No,
I think it's negative 2. They both go from 0 to 2.
They both go from 0 to 2 like this.
I think the first one, the inner one would be 0 to 4.
0 to
And-
5.
Where the pi is coming from?
If you put these on your limits, what kind of region are you describing? What are you saying?
Rectangle.
Let's say this is dx dy. What are you saying when you write this dx dy?
dr d theta.
No, what is this saying as written? 0 to 2, 0 to 2, dx dy. What does that mean?
Integrate x from 0 to 2, integrate y from 0 to 2.
It means your x is going between 0 and 2, and your y is going between 0 and 2. What kind of region does that describe? That's not a circle.
Square, no?
It's a rectangle.
It's a rectangle. X goes from 0 to 2, y goes from 0 to 2.
So,
You have described to me a rectangle. Where do you see a rectangle here? If you have constant limits, you're describing a box or a rectangle. It has nothing to do with this object.
4 minus.
Yes.
Why I can't go to 4 minus r? Like do polar.
You tell me. I'm asking you guys how to set it
Oh,
up. You
4
tell me
minus
what to
r,
write.
dr d theta. Yeah, go ahead. And then do, the r can go from, it's 2, and then, you know, from 0. Oh, y'all leaving it up to me? Let them, now.
No, go on,
4
continue.
minus r is the
Preach.
dr d theta. And then,
So you want to switch to cylindrical is what you're telling me, right?
or polar, whatever y'all.
Yeah, polar or
It's
cylindrical,
easier.
whatever.
It's
What does
easier
the
that
dA become if you're switching to that coordinate system?
R dr d theta.
R dr d theta.
yeah,
So be 4 minus r.
What is R?
Radius.
Radius. What is theta?
The angle.
The angle, okay. So describe it to me. What do we look for?
Oh, because the
What would
radius-
this expression become?
4 minus r.
R squared.
R squared.
4 minus r squared. Okay. Now tell me about the limits. Yeah.
The inner one is 0 to 2,
So my r is going between 0 and 2,
so,
and the other one is 0 to 2 pi.
0 to 2 pi. That integral would give us the volume. Where did these numbers come from? What were you looking at to set that up? Yeah.
So the intersection is a circle, so, and the radius of the circle is 2. So you get 0 to 2. Like the region of the intersection is a circle of the xy plane. And then-
Where does the circle, it comes, the intersection is where? The intersection is in the plane z equals 4.
Yeah, I think it forms 4.
Okay, so what do I look like to set this up? Should I be looking in the plane z equals 4, in other words? When I think of a double integral, where are these limits coming from on a double integral? Does it come from the object itself?
The polar coordinate, you kind of switch it into polar coordinates, it's a circle.
This circle right here?
Yeah.
No.
Ain't it the one you kind of created mentally to just do the problem?
Yeah, where is it created mentally?
In my mind.
On this picture, where would it be created?
On the top?
In the
No,
middle.
we're just to the right, to the left. What? It comes from a region of projection. You need
said
to
you wasn't doing
project
projection, I
down. So the shape you're imagining setting up these limits for on a double integral comes from the shadow when projected into a certain plane. So because I was thinking of this in terms of dx dy, I need to know about the projection into the xy plane. So I imagine there's a light shining above this object down. The shadow, if I look in the xy plane, is going to be a circle with radius 2, and it's the entire circle, which means my angle goes from 0 all the way around to 2 pi. If I want to set up a double integral, I don't look at the object, I look at the shadow that the object projects in the plane of the variables of consideration. So if I'm doing something dx dy, I look at the shadow in the xy plane. If I'm doing something dy dz, I look at the shadow in the yz plane, etc., etc. You guys need to brush up on your calc too.
Not me.
So what we'll be doing, Calc 3 should be an afterthought. Like the real work comes before this. And then you're going to have to do this to answer a problem. So if you have trouble doing this, okay, this is what I mean. It's going to be very important, being able to set things up. There are going to be times, so that's how you would do it in Calc 3. You project into certain planes. In 392, you are going to actually generalize this. You will be able to actually do it in some arbitrary surface. Okay? So when you're doing Calc 1, for example, you kind of set up an integral when you wrote something like f of x dx, right? From a to b. What you're actually doing is, what you are visualizing is there was some function f of x, and your a and b are always running on the x-axis, right? If this was a dy, it's always running on the y-axis, right? But the idea is you always had to sort of project onto an axis, right? What if we don't want to project onto an axis? What if there's some random curve over here floating in space and I want to integrate on that curve without a projection? That's what you're going to learn in this class. Right? So if you don't know how to project onto a straight line, projecting onto some random weavy curve is going to be trouble. Okay. Anyway, I'm not actually going to do any 392 today. I kind of feel lazy. But I do have a gift for you guys. Your first quiz of the semester. I said we have a quiz every week. I was not kidding. This is a week. So put your stuff away. And I'll see you guys later. You had a question? Someone's raising their hand back there.